Okay, hi again. Thank you for the opportunity to talk. Well, I will tell you about a part of my doctoral work in which we are investigating the influence of different magnetic structures in the corona, in the solar corona, that can influence the flux group evolution. So, okay. Among the huge variety of solar activity, we have, for example, that the flux ropes can erupt and become a coronal mass ejection, that are eruptive events that release energy and plasma from the solar surface to the interplanetary medium. And they are the main responsible to the stronger geomagnetic storms here on Earth. And that's why it's very important to understand when one of those events could occur and how they will propagate, in what direction, and when they can arrive to the Earth. So it's very well known that the magnetic structures in the corona, such as those that we can see here in the image of the solar eclipse, are able to deviate the radial direction of the flux rope. And it's also known that the structures that have low magnetic energy, as pseudostreamer and helmet streamers or elepharic arrangements, attract the flux rope to their positions. In particular, the pseudostreamers to this region, and the elepharic arrangement or hermet streamer to this sheet. Okay, in this opportunity, we will analyze the influence of pseudostreamers that are regions where the magnetic field or two lobes are two close lobes or arcades are capped by coronal holes of the same polarity and there is a null point formation here in this region. Here in these images from AIA, we can see the shape of these pseudostreamers, and the stars show the position of the null point. Here we have, for example, the flux rope inside one of the lobes. So we use numerical simulations for analyzing interaction of these two structures because this is how we can isolate the scenario. We don't have other magnetic structures in the corona that are bothering us, and then we can know effectively how the pseudostreamer influence that. So in our model, we include a flux rope, just the same magnetic configuration as Mariana showed you in the previous presentation. And also we have the magnetic field of this pseudostreamer. And what we do was to change the parameters of the pseudostreamer. We changed the head of the null point, and we changed the width of the lobes and changed the magnetic field of the background. And also we changed the relative position between the pseudostreamer and the flux rope. So we obtained a lot of simulations, and here I just present some of them that are representative of the whole study. And so the main thing is that we get two different configurations. In one, we have the flux rope, that is the yellow dot, inside the pseudostreamer. And in the other cases, the flux rope make like his own channel to go outside. I just want to tell you about one part of our result, that is if the flux rope can or cannot erupt in this scenario. So we have, for example, these two different cases where the flux rope is like in the same position in a very similar pseudostreamer, and this case have a lower magnetic field than this other one. And here in magenta, we have the evolution of this case, and in purple, we have the evolution of this other case. And as you can see, the PS1 case is able to erupt, to leave the solar corona, while PS2 came back and followed to the surface of the sun. So when we analyze what is happening during the evolution, we can see that the first case expands. The flux have a lot of expansion, and also the magnetic field of the lobe that is enclosing this flux, I mean the magnetic cage, is deformed and shaped like a log around the flux rope, while this other case is much more rigid and the flux rope is not able to expand. And also, if we see the color labels, we can see that here we have a lot of much more magnetic field. So this cage is stronger than this other one. Okay. So here I show you the evolution, the complete evolution of this case, where you can see how the flux rope at the beginning start racing, but the magnetic cage seems to be pushing it back, and after a while, the flux rope starts to fall down and also to lose its identity. We see the formation of many islands around it. Yeah. So how we measure the difference between this case and this other one? Well, we see that this magnetic case, this line that's overlying the flux rope, seems to be the cause of why this is not erupting. So we decide to measure its magnetic flux. And we do that just taking into account this field path, and then we measure for all the cases we have. But for example, here we have the magnetic flux of these magnetic cases for the eruptive cases and for the non-eruptive cases. And we can see that the magnetic flux cage for non-eruptive cases is much more larger than for the other ones. So this magnetic cage also is producing the non-expansion of the flux rope. Here we can see how the cases that not erupt, those in blue and purple, have much more density than those that are able to erupt. In gray, we have the coronal density. So it means that these cases that not expand are not able to buoyant. And then it will be a problem also for the eruption. Well, okay, in conclusion, we made all these simulations and we found that the magnetic gauge that has the flux rope is exerting pressure towards the coronal, towards the surface coronal, and also is preventing the expansion of the flux rope. And the amount of magnetic flux that has this gauge is determining in whether the flux rope will erupt or not. So, well, this is all. Thank you very much. Is there any question? Okay.
So in one of your results, in one of the graphics, it appeared to be another null point. Maybe I'm wrong.
Okay, yeah. Yeah, I forgot to mention that, but yeah, in all the cases, we have, in fact, two null points. Okay, this one. We have the original null point of the pseudostreamer, and also when we sum the both magnetic structure, a second null point appears. This is very important for the whole trajectory of or the whole evolution of these cases, but I have not time to mention that.
So in the two results that you explained more, it appears like there is one that has a null point and another one that isn't as strong as the
Okay,
other.
you mean this one is much
It's stronger than the other one.
Okay, both of them has it's bigger region of low magnetic energy, yeah, and also this is closer to the flux rope, Okay, in this case, even it's larger the magnetic region of low energy, it doesn't seem to affect that much the evolution. But if when the null point is nearer the flux drop, it makes much more force, exert more force toward it, and then these cases are faster at the beginning than these other ones, even after they cannot erupt.
Okay, thank you.